4 equals -1. All right. Any idea how to solve something like this? Kind of, oh no, I'm sorry. This is the kind we couldn't do. Never mind. Whoops. -3 plus 4x equals equals 12. 12. Could you try solving something like this for me, please?
Yes. Is it x equals 3.75?
Okay, did you add 3 to both sides?
Yes.
Okay, so that's 4x equals 15. Very good. Divide by 4. And I threw in a little wrinkle there with the decimal. All right, so let's look at another one here. Let's go let's go x divided by -2 plus 6 equals -9. Positive, let's do +9 there. All right, so again, you look at the side with the variable, and you decide what you're going to undo.
X equals 1.5.
So did you subtract 6 from both sides?
Yes.
All right, subtract 6. So you have x divided by -2 equals 3. Multiply by -2. And then x equals -6, like that.
Oh, okay.
All right, so let me give you another one here to try. Let's just kind of review from last time, trying to figure out where we might have gone. So let's go 5 plus 3x equals -1. -1.
X equals -2.
Looks pretty, that sounds pretty. It's you subtract 6, subtract 5 from both sides. 3x equals -6, divide by 3, divide by 3. X equals -2. Sorry, you're waiting on me, aren't you? I'm so sorry. I thought we were working on a new problem. 3x minus 1 equals, let's see here. Let's go x divided by -2 plus 1 equals -3. Last one, then we'll move into some more challenging problems.
X equals 8.
You got it. Very good. Okay. So now we move to questions. They're called multi-step, solving multi-step equations. And let's see here. A see if I can pull a few of these up. Okay, so there's before we get to that, a couple things we got to review here. Can you tell me, and this is going to seem silly, but what is 2 plus 3?
5.
5. What is 2x plus 3x?
5x.
5x. Okay, very good. Just making sure. So one of the strategies in multi-step equations is to combine like terms before you start. Okay, so like I'm going to give you a couple examples here of that. Here's a problem here. 4n minus 2n is 2n equals 4. All right, so then you divide by 2, so n equals 2. Does that make sense?
Yes.
Okay. All right. Now, if I give you, let's look at another problem here. Put something in front of you to work on. All right, so we got minus 12 equals 2 plus 5v plus 2v. What is 5v plus 2v?
7v.
7v. Okay. So now can you solve this from here? Basically, like it's a problem we've been doing, but there's that additional step of being able to simplify.
Yep. V equals 2.
Very good. You subtract 2 from both sides. Minus 14 equals 7v. Divide by 7. V equals negative 2. Very good. All right, let's have you try one here on your own. Wait, did I? Oh, this looks similar.
K equals negative 15.
So I can see how you came up with that. So let's start with combining like terms. Minus 2k minus 3k. They're both negative. So what does that become?
Positive.
Negative 5k.
Oh, yeah.
All right, you're gonna subtract 3 from both sides. Negative 15 equals minus 5k. Divide by minus 5, divide by minus 5. K equals 3. All right, let's look at another one here. All right, so go ahead and give this one a try, please.
R equals 1.
You got it. Divide by -1, R equals 1. Very good. Okay. I think you're getting the hang of this. Would you agree?
Yes.
All right. Now, a couple other things you might see, because we haven't, there's like an infinite, there's a lot of possibilities here. So I mean, I can't cover them all, but generally we're looking at one side of the equation, and this time on the right, the variables aren't like next to each other, but you can still combine them. You got 1x minus 5x. So if you need to, you could rearrange this. This could become 1x minus 5x plus 3. So you can combine these terms. All right, so I'd like you to do that and then try solving this, please.
Okay. X equals 0.
X does equal 0. Very good. Yeah. So when you combine these, minus 4x plus 3, 3 equals subtract 3, you get 0 on the left. 0 equals negative 4x. Divide by negative 4. X equals 0, like that. All right, very good. And so you can also have the same thing here with numbers. This is not a great example, so I'll just work it out. But you can always combine numbers first. So x plus 3 minus 3 equals minus 6. 3 minus 3 is 0. This just becomes x plus 0 equals minus 6, or x equals minus 6, like that. So the other type of problem you'll see, and we gotta do a little bit of warm up for this is, let's say I put something like this, like -2 in front of a 3x minus 5, something like this. And do you remember how to distribute the -2 in parentheses here?
Yeah.
Okay, what does that become? So let's look at a problem here. Right, so you distribute the -3 in here. So -3x minus 6 equals, and then you solve it just the way that um, all right, so do you want to try solving this from here, please?
Yep.
All right.
X equals -4.
Okay, so you get 12 equals -3x. Divide by -3, divide by -3. X equals -4. All right, very good. So let me do another problem here with you, or have you try this one. This one's really similar. Sorry, and this probably isn't super interesting, but what we got to work on today. Go ahead and give this a try. I'm gonna just step away for 30 seconds. I need to get some water. I'll be right back though. Same type of problem as the last. All right, how are you looking on this one?
I think it's R equals 5.
Okay, let's take a look here. A lot of steps here. So -12r plus 24 equals -36. Subtract 24 from both sides. -12r equals -60. Divide by -12. R equals 5. Very good. Okay, let me have you try one more. I always say that, right? Just one more, right?
X equals -7.
Okay, that does sound pretty good. Now, here's another approach that I want to show you to this problem. And it works because 24 is divisible by 6. You can actually divide first, which I know you didn't, you probably distributed in, but you have 4 equals -x minus 3. Add 3 to both sides. 7 equals -x, divide by -1. X equals -7, like that. Any questions on that?
No.
Okay, so the next type of problems we'll see, they get a little more complicated because you first distribute, but then you got to like collect terms or move terms around. So let me try to show you an example of that here. Um, is this too easy, or are you okay with the pace that we're going at?
I'm okay with the pace.
All right, so fair enough. So when I distribute the 6 in, I get 36v plus 36 minus 5 equals 1 plus 6v. Okay. 36v plus 31 equals 1 plus 6v. Subtract 6v from both sides. 30 plus 31 equals 1. 30v plus 31 equals 1. So notice like you get it down to an equation like we've been solving, then you move the variable one way or the other, depending on how that goes. Actually, maybe we have not seen that. Have we seen problems where you have to choose which way to move the variable?
Um,
We have not, have we?
no.
Let's kind of take a divergent path here and look at a few of those. I got to pull up a worksheet for us to be able to do that. We're almost there. All right, solving systems of equations. Why can't I find it? Systems of equations. It's called something else. All right, so I'm gonna have to handwrite some of these. So let's say I asked you to solve something like this. 3x minus 4 equals minus 6x plus 5. Okay, so this time there's variables on both sides of the equation. Right, and what that means is, well, you have to move from one side to the other. So you're going to add 6x, 9x minus 4 equals 5, add 4, 9x equals 9. Divide by 9, x equals 1. So you move, and this is important, you move from the smaller to the larger. Always smaller to the larger. Okay, so the -6x is smaller. Like I know maybe we had some discussions about which is smaller, which is larger. Well, uh, it is uh, uh, it is always the smaller to the larger. So -6x, add 6x to the other side. And so let me have you try a problem here to see if this makes sense. Let's go. Okay, this one will do. 3x minus 9 equals minus 5x plus 7. So go ahead and give this a try, please. Okay, I'm going to step away for like a minute or two. If you get done with this, just take a rest and we'll reset as soon as I get back.
Okay.
How are you doing on that one? Alejandro, you there? Here's your muted.
Sorry.
It's okay. How are you doing on that one?
It is x equals 2.
Let's take a look here. Did you add 5x to both sides?
Yes.
Okay, so you have 8x minus 9 equals 7. Adding 9 to both sides. 8x equals 16, divide by 8. X equals 2. Very good. All right, so let's try a little bit of a more difficult one. Let's try sorry, I gotta get my thing here. So minus 2x plus 3 equals minus 5x minus 6. Which is smaller, the minus 2x or the minus 5x?
Minus 2x.
The minus 5x is small. That's actually like further from 0. So you're going to add 5x to both sides. Sorry, I'm just trying not to do everything for you here. So see if you can work the problem out from here.
Okay. X equals -3.
We got 3x plus 3 equals -6. Subtract 3, subtract 3. 3x equals minus 9. Divide by 3, divide by 3, x equals minus 3. Like that. Let me give you another one here to look at. All right, here's one to try. Minus 6x minus 3 equals minus 8x minus 7. Go ahead and give that a try. I'm going to step away for a minute or two. I'll be right back. We'll talk about the answer. What did you come up with?
X equals -2.
X equals -2. All right, we're going to add 8x to both sides. -3 equals, I'm sorry, -2, I'm sorry, 2x. 2x minus 3 equals -7. Add 3 to both sides. 2x equals -4. And you're going to divide by 2. So x equals -2. All right, we're going to go ahead and stop there for today. Really good job. Appreciate the effort. We'll see you on Thursday at our same time, but that is it. Hope you have a great rest of your day.
You too. Bye.
Thanks. Bye now.